Hi students, welcome to my channel Physics Universal Classes. Our today topic set some problems to discuss based on the integration and differentiation problems. This type of problems asking in the previous NEET and mains question paper. Okay, first problem, the displacement time equation of a particle moving along x-axis is x is equal to t square minus 5t plus 45. This is the equation where x is in meters and t is in seconds. Find out first one, velocity of the particle at any time t. Next, velocity of the particle at t is equal to 2 seconds. Next, c bit time at which the particle is at rest position. Is at rest position, final velocity will be 0. Then find out time taken. Fourth one, acceleration of the particle at any time. Acceleration, that is equal to the rate of change of velocity with respect to time taken, that one. Last one, acceleration at t is equal to 2 seconds. Is very important problem and very easy problem, students. First, write the equation x is equal to t square minus 5t plus 45. First, a bit, velocity of the particle at any time. Velocity is equal to displacement by time taken. Then v is equal to dx by dt, and v is equal to d by dt of t square minus 5t plus 45. With respect to time taken, v is equal to 2t minus 5. The velocity of the particle at any time, that equation v is equal to 2t minus 5. That is first bit. First bit finished. Second one, velocity of the particle at t is equal to 2 seconds. In this one, equation v is equal to 2t minus 5 at t is equal to 2 seconds. V is equal to 2 into 2 minus 5. Then v is equal to minus 1 meter per second. Minus 1 meter per second. This is the second bit. Third bit, time at which the particle is at rest. The particle is at rest, then velocity, final velocity will be 0. The final velocity will be 0. In this c bit, v is equal to 2t minus 5. So particle is at rest. Particle is at rest. Then 0 is equal to 2t minus 5. That t is equal to 2.5 second. This is c bit. And d bit, acceleration of the particle. The velocity of, first write the velocity of the particle, v is equal to 2t minus 5. Then acceleration a is equal to dv by dt, that is equal to d by dt of 2t minus 5. Then a is equal to with respect to time taken. Then the acceleration a is equal to 2 meter per second square. This is fourth bit. Fifth bit, acceleration at t is equal to 2 seconds. Acceleration at t is equal to 2 seconds. The acceleration of the particle does not vary with the time. Then the acceleration at t is equal to 2 seconds. Then a is equal to 2 meter per second square. This is the problem. First problem. The next to discuss second problem. Second problem, a particle at rest starts moving along positive x-axis with an acceleration a is equal to 6t. Find the velocity of the particle at any time. Next, to find the position of the particle at any time t if the particle was initially at x is equal to 3 meter. Okay, in this one, very simple, student. This is the previous paper asking in NEET paper question. It's very important question, students. Particle is rest, then is equal to 0. The time is equal to 0. Then x is equal to 3. These are the boundary conditions. Boundary conditions. First a bit, The acceleration is equal to A is equal to 6 into T. The velocity in this one, acceleration is equal to dv by dt. A is equal to dv by dt. In this one, substitute in this formula, A is equal to 60. dv by dt is equal to 6t. Then dv is equal to 6t into dt. Okay, both sides integration are applied. Integration dv is equal to integration 6t dt. Okay, v is equal to 6 into t square by 2 plus constant c. Then v is equal to 2 1s so 2 3s, 3t square plus c. V is equal to 3t square plus c. Okay, we will find the c value. Then the particle is at rest position. Then v is equal to 0. The time also 0 plus c. Therefore, c is equal to 0. And the velocity of the particle v is equal to 3t square. This is the equation number 1. The next, find the position of the particle at any time t if the particle was initially at x is equal to 3. The relation between position and velocity, then v is equal to dx by dt. This is equation number 2. From 1 and 2, then v is equal to 3t square. This is the equation number 1. This is the equation number 2. Okay, from 1 and 2, from equation 1 and 2, dx by dt is equal to 3t square. Okay, dx is equal to 3t square into dt. Okay, integration both sides are applied. Dx is equal to 3t square dt. Then x is equal to 3t cube by 3 plus k. The k is the constant. 3 cancel. X is equal to t cube plus k. T cube plus k. Okay, we will find the value of k by using boundary conditions. Okay, x is equal to 3. 3 is equal to 0 plus k. Then k is equal to 3. Okay, k value substituted in this equation. Then x is equal to t cube plus 3. This is the equation. This is the position of the particle at any time if the particle was initially at x is equal to 3. That value x is equal to 3 t3 t cube plus 3. This is the problem. This is the second problem. The next third problem. Okay, next third problem. A particle travels in a straight line, moves half a distance with a constant velocity of 10 meter per second, and the next half distance with a constant velocity of 5 meter per second. Then find out what is the average velocity during entire journey. Entire journey is a very simple problem. So particle starting from A to reach C passes through B. First half distance d by 2 with velocity 10 meter per second. The next half speed d by 2 with velocity 5 meter per second. Okay, the distance, the speed v1 is equal to the distance s1 by t1, that is equal to t1 is equal to s1 by v1. S1 by v1, the t1 is equal to s1. S1 is the d by 2 by 10, that T1 is equal to the fraction is reverse, d by 20. Next, T2 is equal to S2 by V2, that is equal to d by 2 by 5, that is equal to d by 10. Therefore, total time taken is equal to the T1 plus T2. T1 is the d by 20 plus d by 10. Okay, the take LCM. So 20 is the LCM. So d plus 2d, that is equal to 3d by 20. Therefore, average velocity of the particle during the entire motion, average velocity, so total distance or total displacement by total time. So total distance, so d by 2 plus d by 2, d by 2 plus d by 2 by, so total time 3d by 20, that is equal to 2d by 2 into the fraction, the denominator, the reverse, 20 by 3d, dd cancel, 2 cancel, 20 by 3, that is equal to 6.6, the average velocity. These two cancel, 6.67 meter per second. This is the average velocity of the particle during the entire journey. Hope you like this video. Please subscribe to my channel for more videos. Thank you.